Hi everyone, in this video I'm going to demonstrate how to take derivatives of these sorts of functions using the shortcut method. Now let's have a quick review of the shortcut method. So if we had a formula where y equaled some number constant a by x to the power of n, then the derivative dy dx of this function, we use the power n, we multiply by the coefficient a, so it becomes a times n, then the power on x reduces by 1. That's the shortcut rule. Now let's see this in action. If we were to do the first one here, I really should probably put a, b, c. So for part A, I like to always have y equals, or f of x, so 2x to the 4th minus 7x to the 5th. The derivative dy over dx, so the power 4 times 2 becomes 8, and we reduce the 4 to a power of 3. Then 5 times negative 7 is negative 35, and we reduce the power of 5 to a power of 4. That's the first one. You can see why it's called the shortcut method. The second one, let's do function of x this time, equals 16x, take 12x to the power of 11. Now, this time the derivative is signified by f dashed x, not by dy dx. We usually put dy dx if it was y equaled, and f dashed of x means derivative. That's a 16 there. Now remembering, you don't need to write this, but I'll put in red there to emphasize that pronumeral x really means to the power of 1. So 1 times 16 gives 16. Now what happens when I reduce from power of 1? I end up with x to the power of 0. Again, I've put that in red because you don't need to write that. X to the power of 0 equals 1. So really, that bit is just 16. I'll take those red bits away because they were only there to explain what was happening. Then I have 11 times 12, that's negative 132. X, we reduce the power to the power of 10. That's that one. I'm not going to do the other two because they're quite straightforward. I will make up one of my own here. So ... You can do the other two if you want. Part E. Let's have y equals the square root of x. What on earth are we going to do with that? Well, I'm going to remember that square root is the same as power of 1/2. And if there's nothing in front here, remember this is, again I put in red, you don't need to actually write that, it's like 1 multiplied by. So dy dx in this case, 1/2 times 1 is 1/2. A power of 1/2 reducing by 1, so if I was thinking of a number line, there's 1, there's 1/2. If I reduce by 1, I'm at negative 1/2. So we've done the same thing. I've subtracted 1 from the power. It's now negative 1/2 for the power. And what does that mean? Well, that means 1 divided by x to the power of 1/2. That's what negative powers do. And that's the same as 1 divided by 2 by the square root of x. Power of 1/2 means square root. So again, you wouldn't need to have written this red number 1, and you wouldn't need to have written this number line. That was just my way of calculating what 1/2 take 1 was without messing up. And that's a quick demonstration of how we deal with taking derivatives using the power rule. Thanks for watching.